So hello everyone, my name is THORAT. I am from Computer Engineering Department from MIT Academy of Engineering, and today I am going to present a very important concept from exploratory data analytics, that is the optimization of loss function and best fit line using gradient descents. This topic is the foundation of how mechanism learns patterns from data and how they make predictions in real life. So that's the introduction. In today's world, data is everywhere. Education, business, healthcare, finance, every system generates data. But data is not useful. We need to analyze it and predict future values. For example, predicting house prices from location and size, predicting student marks from study hours, and predicting salaries based on experience. To make these predictions, we use regression analysis, which help us to understand the relationship between input variable x and an output variable y. Our goal is to find a best fit line that can predict values accurately. But choosing the line is not random. We want a line with minimum prediction error, and to achieve that we use optimization techniques, especially gradient descents. So what's linear regression? Well, linear regression is a supervised machine learning method used to predict continuous values. It assumes that there is a straight line relationship between x and y. Our equation goes like y is equal to mx plus c, where the x is the input, y is the predicted output, m is the slope of the line, and c is the intercept, where value of y when x is equal to 0. Our task is to find the best value of m and c so that the prediction becomes accurate. In simple words, linear regression learns a straight line that the best fits the data. So now we'll be understanding the loss function. Once we predict values, we must check how close are the actual values. This difference is called loss or the cost. If the loss is small, our model is good. If the loss is large, our model is bad. The most commonly used loss function is mean squared error, that is MSE. It squares the errors, so bigger mistake gets penalized more and then takes the average. Our ultimate goal is to minimize the loss. So now our next question is why the optimization is needed. There are many possible lines we can draw on a dataset, but the only one line gives minimum error. Optimization means finding m and c values that make the loss lowest. The most popular optimization technique used in gradient descent is to help us efficiently reach the lowest possible loss value. Without optimization, the model will not learn properly. What is gradient descent? Gradient descent is an iterative algorithm. It learns step by step. What does it do? It starts with a random value of m and c. It calculates error. It adjusts m and c to reduce error. It repeats again and again and stops when the loss becomes very small. The word gradient means slope or the direction of the steepest change. The algorithm always moves downhill towards minimum error. This is how machine learns from the data. Then there is this example where our equation is m is equal to m minus alpha and dou L by dou m, and c is equal to c minus alpha and dou L by dou c, where a is equal to learning rate that controls the step size, and we have the partial derivative of loss function which is equal to the direction of steepest descent, where large alpha may skip the minimum and small alpha very slow convergence. It needs a balanced learning rate for stable training. So alpha is equal to learning rate. It controls how big the step the algorithm takes on each update. So basically it means that if we have too large alpha, the algorithm may skip the minimum, and if we have too small alpha, the training becomes slow. Basically we need to have a balanced learning rate to reach the minimum loss efficiently. Then we have steps in gradient descents. First of all, we have to initialize n and c randomly, and then in second step we'll be predicting values using y is equal to mx plus c. Then we'll be calculating loss using MSC, that is mean squared error, then we'll compute the gradients, and then we'll update the MNC, and we'll repeat this process until we get the minimum. This continuous repetition helps the model learn the best possible line. So here we have taken an example where x is equal to 1 2 3 and y is equal to 2 3 4. So we start with when m is equal to 0 and c is equal to 0. So we get the predicted value is equal to 0 comma 0 comma 0. So we have a very high error. So what we'll do is we'll apply the gradient descent and gradually adjust m and c. After some update, we'll get m is equal to 1 and c is equal to 1. So like if we put our values, that is 2 3 and 4 in the equation, we'll get the loss of 9.67. but if we put m is equal to 1 and c is equal to 1 and then we apply the formula, we get the equation as y is equal to x plus 1 and the prediction is 2 comma 3 comma 4. That is the perfect fit and will be having zero loss. So this shows that how gradient descent improves perfect prediction gradually. So the actual value of y is 2 comma 3 comma 4 and obtained solution is 2 comma 3 comma 4. So the learning rate decides how quickly the parameters are updated. Basically it tells that if the alpha is too small, it takes many iterations, and if the alpha is too large, it overshoots and may never reach the minimum. So we have to keep the ideal alpha for smooth and stable conversions. So in conclusion, to summarize everything that we have discussed today, regression helps us to make prediction about continuous outcomes like prices, marks or salaries. The loss function measures how close or far our predictions are from the actual values. Our goal is to always minimize this loss. That's what optimization is all about. The greatest descendant is the most powerful and widely used optimization algorithm for doing it gradually. And just to adjust the parameters like slope and intercept until the model finds the most accurate fit possible. This concept may look simple at first, but it is truly the foundation of modern artificial intelligence. Every deep learning model, whether it's for speech recognition or computer vision or NLP, that is natural language processing, depends on gradient descent for learning. So understanding how it works gives us a deep insight into how machine actually learns from data. In other words, this small concept powers some of the biggest innovation we see today, from recommendation system on Netflix to self-driving cars and even ChatGPT itself. So the references I have taken from class notes, some of the YouTube tutorials, and I have researched about some articles. So yeah, thank you so much for listening. I hope this presentation helped you understanding how optimization and gradient descent work together to make machine learning possible today. So yeah, thank you so much.